Yes, my dear students of 10th standard, we are revising about types of chemical reactions. Already we learned some topics, the types of chemical reaction. So when you see the introduction, already we revised. Once again, I would like to revise something. So in the introduction part, it is given chemistry mainly focuses chemical reactions, and there are physical changes, chemical changes. Physical changes are temporary, but chemical changes are permanent. And during the chemical reaction, atoms of the reacting molecules rearrange to form a new molecule, and old bonds are break, new bonds are formed. During the bond breaking, energy is absorbed. During the bond formation, energy is released. And usually we write a chemical reaction in the form of word equation. And next step, we have to convert it in the form of a molecular formula. Then we have to balance the equation according to the law of conservation of matter. Then the types of chemical reaction, we learned about combination reaction. The combination reaction also, there are three categories: element compound, compound element compound, then compound react to give another compound. And the decomposition reaction, which is completely opposite to that combination reaction, because in the combination reaction, two reactant combine to give a single product. But here in the decomposition reaction, a single compound split into simpler substances. A single compound split into two or more simpler substances. And based on this energy observation, because decomposition requires absorption of energy, there are three types of decomposition. Thermal decomposition, heat energy is absorbed for the decomposition. Electrolytic decomposition, electrical energy is used for decomposition. Photo decomposition, light energy, sun energy from the sun is used for the decomposition of the compound. Then single displacement reaction. The single displacement reaction, see, one of the element of the compound reactant is replaced by the element reactant to form a new compound. And next one, see, double displacement reaction. Here the reactants compounds interchange their ions. The reactant compounds interchange their ions to form new product. This is also called metathesis reaction, because of the interchange of the ions or replacement of cations by cations. And there are two types of double displacement. Precipitation reaction, if precipitate is formed during the reaction, that is called precipitation. Neutralization means an acid is neutralized by a base to give salt and water, that is called neutralization reaction. And combustion reaction, the combustion reaction on which a reactant rapidly combine with oxygen to form oxides and liberation of heat energy. For example, the burning of LPG, hydrocarbons, like that. And in the classification based on the direction of the reaction, reversible reaction and irreversible reaction. The reversible reaction, that is a reaction that can be reversed. That means the products can be converted back to the reactant. So there are forward reaction and backward reaction. Usually this type of reactions are indicated using the arrow mark, both the side arrow mark, that is forward reaction for backward reaction. Then in the irreversible reaction, that is a reaction that cannot be reversed, it is called irreversible. Normally the combustion, the burning reactions, the burning processes, and this type of reactions will not be reversed again, because the product will not recombine to give the reactant. Then already we learned about the rate of a chemical reaction, that is nothing but it is a measurement of the amount of reactant or product before and after a specific period of time. So rate of a reaction is the change in the amount of concentration of any one of the reactant or product per unit time. And the rate of the reaction is very, very important in the designing process and also in the food processing unit. This type of reactions are considered as very important one. Then next topic, factors influence the rate of the reaction. And there are some factors which are going to increase the rate of the reaction. The speed can be enhanced because of some of the important factors. For example, see, the rusting of iron will take place faster in presence of acidic nature. So actually rusting means what? That is the formation of rust on the iron, hydrated ferric oxide, that is called rust. Hydrated ferric oxide is the rust. The phenomenon of formation of rust is rusting. Normally rusting require oxygen, water, these are the main elements, but in presence of acidic nature the rate of rusting will be faster, the formation of rusting will be faster. That's why see, the carbon dioxide present in the atmosphere going to influence the rate of the reaction in the form of carbonic acid and increase the rate of the reaction. And you can see there are some factors are given. That is first one, see, nature of the reactant. The nature, see, the reaction of sodium with hydrochloric acid is faster than that of acetic acid. Do you know why? Hydrochloric acid is a strong acid than acetic acid and thus more reactive. So the nature of the reactant influences the reaction rate. It is simply given. So already you learn in the lower section that there are two types of acid, organic acid and inorganic acid. So organic acids are normally weak acids. Inorganic acids are strong acids. Organic acids are acids obtained naturally from the living being, like citric acid, lactic acid. These are the acids from the vegetable matter, animal matter. So these acids are weak acids because these acids will not completely dissociate into ions during the reaction. That's why they are called weak acid. But inorganic acids are strong acids, acids obtained from the mineral, also called mineral acid, like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. These acids are strong acid because these acids completely dissociate into ions during the chemical reaction. Completely dissociate into ions. So more number of ions react with the sodium or any metal to form product at faster rate. That's why you see, normally inorganic acids are strong acids. So here hydrochloric acid is given, that is strong acid compared to acetic acid. Acetic acid is a weak acid, that is organic acid. So hydrochloric acid is strong acid, so it going to increase the rate of the reaction. The reaction rate is faster. So it is given, see in the equation, sodium with hydrochloric acid, sodium chloride and hydrogen. The hydrogen, the evolution of hydrogen is faster in this reaction. And the second equation, it is given sodium with acetic acid, CHCO, which is acetic acid, that is organic acid, that going to combine to form a salt, that is sodium acetate, sodium ethonate, CH3COONA, sodium ethonate. The liberation of hydrogen, that liberation of hydrogen is very slow rate, very slowly liberate. So because that acetic acid is weak acid. Then concentration of the reactant. So already you learn concentration. It is called concentration. The term concentration, which is going to refer the, it is a characteristic used to measure the how much of solids or solid is dissolved in the solution. So normally it is generally expressed in terms of mass, that is in grams, or number of particle moles per unit volume. So already we learned in the previous lesson, solution lesson, the amount of solid present in the given amount of solvent, that is called concentration. So here the amount of solid or substance present in the certain volume of solution is called concentration. So more concentration means more particles in the given amount of solution. More concentration means more particles, more ions, the given volume of solution. More ions means the rate of the reaction will be automatically faster. So here it is going to see granulated zinc react faster with 2m hydrochloric acid than 1m hydrochloric acid. Granulated zinc means fine particles of zinc react fast with 2m. That m refers the, that is the unit to measure the concentration. It is called molality. The m refers molality, that is the number of moles of solid in 1000 gram of solvent. Number of moles of solid in 1000 gram of solvent, it is called molality. So 2m HCl means more hydrochloric acid particles are there, more solid particles are there, more ions are there. So more ions vigorously react with granulated zinc to give zinc chloride and hydrogen. Zinc chloride and hydrogen. You can write the equation. I can give the word equation. You can write in the form of using symbols and formula. Zinc plus hydrochloric acid gives zinc chloride plus hydrogen. Zinc, what is the formula? Zinc Zn, hydrochloric acid HCl gives zinc chloride ZnCl2 plus hydrogen. Hydrogen is a gas, so we have to put upward arrow mark. The next one, see temperature. So temperature also already have learned in the previous and the solution lesson. Temperature increase means the solubility also increase. Similarly here, temperature increase, the rate of the reaction also increase. So temperature is directly proportional to the rate of a chemical reaction. So most of the reactions are go faster because of the high temperature. So addition of temperature increase the rate of the reaction. So here it is given, see what is the reason, because more heat means the energy provided by heat energy helps to break more bonds, and because of this the rate of the reaction will be increased. So here one example is given, calcium carbonate reacts slowly with the hydrochloric acid at room temperature. At the same time, when this mixture is heated, the reaction rate increases. What is the formula of calcium carbonate? CaCO3 plus hydrochloric acid HCl gives, on heating, gives arrow mark. Above the arrow mark you have to put that heat symbol, triangle symbol. Then calcium chloride CaCl2 plus CO2, upward arrow mark because it is a gas, plus water H2O. So on heating the reactant, the rate of the reaction will be increased because the energy supplied provides and helps to break more bonds and speed up the reaction. Then see do you know food kept at room temperature spoil faster than kept in the refrigerator? What is the reason? Because in the refrigerator the temperature is very low. So temperature decrease, the rate of the reaction decrease, the rate of spoiling food also going to be decreased. Then next one, see pressure. Next one, pressure. That is also already learned in the previous solution lesson. Pressure is directly proportional to the solubility of gases. So when pressure increases, solubility also increase. That you learned in the previous lesson. Similarly here, pressure is directly proportional to the increasing the rate of the reaction. When pressure increase, the rate of the reaction also increase. This is normally in the gaseous reactant. When the reactants are in the gases, for example, in the solubility of carbon dioxide in water, when they apply pressure, normally the carbon dioxide will be easily or highly dissolved in water. So this type of process is used in the beverages, in the soft drink preparation. They use to dissolve carbon dioxide by applying pressure. So this is because on increasing pressure, the reacting particles come closer and collide frequently, so the rate of the reaction increase. Then next one, see catalyst. What is called catalyst? Catalyst is nothing but it is a type of substance, a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. So it is also given here in this para, a catalyst is a substance which increases the reaction rate without being consumed in the reaction. So the catalyst will not take part in the reaction, but it going to simply alter the speed of reaction. It increase the speed of reaction. It increase the rate of reaction. That is the main function of the catalyst. And see, in certain reaction, addition of substance as catalyst speed up the reaction. For example, heating potassium chlorate. It decomposes to potassium chloride and oxygen gas. So this reaction is normally slow rate at the room temperature. And see, that is at on heating. On heating, the potassium chloride decomposed into potassium chloride and oxygen gas, that is at a slow rate on heating. But by the addition of manganese dioxide MnO2, the rate of the reaction will be increased. So manganese dioxide acts as a catalyst which is going to stimulate the reaction, speed up the reaction, and manganese dioxide will not undergoing any permanent chemical change in this reaction. So you can write the equation. I can give word equation. You can write potassium chlorate formula KClO3. Potassium chlorate. Arrow mark gives, above the arrow mark he would put heat symbol, triangle symbol. Below the arrow mark he would put MnO2. That is a catalyst, manganese dioxide, and potassium chloride KCl plus O2 oxygen plus O2 oxygen. They have to put upward arrow mark because it is a gaseous product, and you have to balance the equation. Potassium chlorate KClO3 gives, on heating, a manganese dioxide catalyst, potassium chloride KCl plus O2 gas. And next one, see surface area of the reactant. Surface area. So actually there is a branch of chemistry which deals with the nature of the surfaces and changes taking place on the surface. But here, what is a surface area? When the reactants are in the form of fine particle, in the form of dilute solution, in the form of fine particle, see the reacting elements are going to combine to give the product at faster rate. So here see it is given when solid reactants are involved in a reaction, solid reactant in the form of crystal. For example, powdered calcium carbonate. So it reacts slowly. That is, for example, listen, when solid reactants are involved in the reaction, their powder form react more readily than the solid form. See, powdered calcium carbonate react more readily with the HCl because that calcium carbonate is in three different form. Already learned calcium carbonate, the form of marble chips, the form of limestone, chalk, all are calcium carbonate only. So calcium carbonate formula CaCO3 plus HCl, hydrochloric acid HCl, gives CaCl2, calcium chloride, plus carbon dioxide CO2 gas, plus water H2O plus water. You have to balance the equation. So when the calcium carbonate is in the form of powdered, it provide more surface area for the reactant. So because of this, the rate of the reaction will be increased. See, powdered calcium carbonate increase the surface area, provide more surface area, so more collisions of the reacting particles will take place. Because of this, the rate of the reaction is automatically increase. So there are 6 factors which alter the rate of a chemical reaction. First one is nature of the reactant. Nature, whether it is organic or inorganic. Concentration, whether it is 2m HCl or 1m HCl. Temperature, when temperature increase, automatically the rate of the reaction also increase. Then pressure is directly proportional to the rate of a reaction. And catalyst is a substance which is going to increase the rate of reaction without undergoing any permanent change. Then surface area, more area means more collisions of the reactant particles, so the rate of the reaction will be increased. So these are the important 6 factors which alter the rate of a chemical reaction. So you have to go through thoroughly, prepare well, and next state of equilibrium we will learn in the next class. And prepare the next objective test solution lesson. You have to prepare all the textbook evaluation inside the book also. You have to prepare well, get ready. So till that, be safe and prepare well. Don't waste the time. Thank you. God bless you.